Okay, let's continue on atelectrauma. So this is a collapsed alveoli here and an open alveoli. So to get this collapsed alveoli to open, so from closed to open status, this is called recruitment. And this is requiring to provide the alveoli with the opening pressure. We talked about it. And this is usually much higher, the closing pressure that we'll talk about in a second. How do we recruit alveoli? The PEEP that usually we use is not enough because it's usually targeted to stay above the closing pressure. So what we do a transit increase in the PEEP. Usually PEEP, let's say we use PEEP normally of 5 or 10. But to do these recruitment maneuvers, sometimes we give for a very transit period PEEP, let's say of above 20 or up to 30. Very short period of time, very transit, to get the alveoli from the collapsed status to the opening of collapsed state to the opening state. So we provide a pressure that's above the opening pressure. This is we call recruitment. But the usual PEEP we use is really to prevent the derecruitment. This changing the alveoli from an open state to a closed or collapsed state, this is called derecruitment. So the usual PEEP is to prevent this process, to prevent derecruitment. That's the usual PEEP. So the usual PEEP is usually we set it equal or above the closing pressure of the alveoli. Okay, so that's, if you wonder what's the benefit of PEEP, positive end expiratory pressure, this is the main benefit to prevent derecruitment. And by minimizing derecruitment, it can decreasing derecruitment, improve oxygenation. Simple. As well as the recruitment maneuvers will improve oxygenation. Now let's give you just this assumption. What if we give a PEEP of 12, for example, but it did not prevent derecruitments? The alveoli were derecruited and got from here to here. That means the more derecruitment, the less open alveoli, right? That means less space for tidal volume. That means less compliance. That means over distension of the alveoli. That means barotrauma. More barotrauma, right? And not just that, this over distension can compress the capillaries, leading to worsening shunts and decrease O2. See, sometimes the increased PEEP can be detrimental because of this. If it doesn't prevent derecruitment, it can be really detrimental. And that's something when you look at your patient, look at the ABG, look all the respiratory mechanics, you have to decide if your PEEPs are doing the job or not. So that's basically atelectrauma. Atelectrauma more pronounced in ARDS, which we'll start talking about it shortly.